Black holes are so powerful that they can bend light and even trap it, meaning nothing, not even light, can escape their gravitational pull. Yet they exist all over our galaxy. In fact, the supermassive black hole at the center of our Milky Way is estimated to be 4 million times more massive than our Sun. Scientists are still trying to fully understand how these incredibly powerful objects form and interact with their surroundings, and while doing that, they've made a terrifying discovery. It's about to change everything. Join us as we dig deeper into black holes and what they could really mean for the future of humanity. But to get to that, we have to understand black holes first. What is a black hole? Black holes are mysterious celestial objects that have captivated scientists and the public alike. According to Einstein's theory of relativity, time is the fourth dimension, with space and time being intertwined. In this case, gravity isn't a force at all, but rather a curvature in space-time caused by mass. Visualize the surface of a trampoline with a bowling ball placed on it. The ball causes the surface to sag, pulling smaller objects into the dip. With black holes having an infinite density, they create an abyss in space-time that is nearly impossible to fathom. Scientists are still uncertain of where exactly matter goes when it's pulled into these mysterious and powerful force fields. But the general idea is that, just like the trampoline, all matter is drawn into a deep and dark void. The enigmatic concept of black holes was first coined in 1967, though the idea had been around since 1783. It was John Michell, who's considered the father of the black hole theory, who suggested that while they are invisible, these intense gravity fields might be detected if they happen to have a star orbiting them, while others built on it. During the 1930s, theorists using Einstein's general relativity theory showed that sufficiently massive stars could collapse under their own gravity and turn into black holes. Mitchell's prediction was confirmed in the early 1970s when astronomer Louise Webster, Paul Murden and Thomas Bolton observed a massive yet invisible object orbiting a blue star from 6,000 light-years away. The object was codenamed Cygnus X1 and is regarded as the first black hole to be identified. This remarkable discovery proved that despite their invisibility, these mysterious objects could indeed be detected, even though we can't really see them like we can see stars. The science behind black holes is truly remarkable. Not only do we know that there are potentially as many as 400 million of them in our own Milky Way, but also that at least 2 trillion galaxies in the observable universe have supermassive black holes at their center. This means that areas of space containing multiple galaxies can contain hundreds or even thousands of supermassive black holes. It's incredible to think about how much power must be contained within these mysterious objects, and it begs the question of what other secrets they may hold. Do black holes actually exist? While there was a time when black holes were chalked up for being just a theory, there's no denying their existence today. Thanks to the incredible breakthrough of the Event Horizon Telescope collaboration, we now have a glimpse into what many considered unseeable. This first-of-its-kind image was taken by a network of 8 different telescopes pointed towards Messier M87, a galaxy some 55 million light-years from Earth. It captivated the world with its hauntingly beautiful display of the supermassive black hole at the center and its accretion disk, a spinning, swirling mass of superheated dust and gas around the event horizon. The dark center is actually the black hole's shadow, thanks to its immense gravitational pull that draws in. Not even light itself can escape. The radiation emitted from matter, billions of degrees in temperature, was captured by the EHT and has been presented to us as a remarkable image filled with information. Are black holes really holes? When it comes to black holes, the first general idea that people think about is that black holes are actual holes in space, and the concept of wormholes is often brought up. Wormholes are theoretical tunnels in space-time that could potentially provide a route for traveling great distances instantaneously, like gateways through space. Although Albert Einstein and Nathan Rosen proposed the idea in 1935, there are doubts that they could occur naturally or remain stable long enough to be of any use. Even if they did, their size would be far too small for anything more than a single particle to pass through them. For this reason, it is unlikely that naturally occurring black holes could ever form the kind of portals seen in pop culture. The fictional depiction of black holes as time-traveling doors may have contributed to the common misconception that black holes are holes in space-time. In reality, it's basically an object like any other, but with immense gravitational force, so powerful that it can even trap light and distort the shape of space-time around it. The term hole was used due to its ability to draw things in and not let them out. But it is important to understand that a black hole is not actually a hole at all. It just sucks everything into basically what we would describe as a hole, because what goes in doesn't really come back out. So what would happen if you fell inside a black hole? A black hole is a solid disk of darkness that appears impenetrable from the exterior. However, once you cross into its event horizon, the darkness gives way to a strange illumination. The light flooding in from outside the event horizon penetrates this boundary without obstruction, creating warped and distorted images. The interior of a black hole can be extremely bright despite its dark exterior. Though the one-way window at the horizon of the black hole, you can view the universe beyond, watching it as it evolves over thousands or millions or even billions of years. While there will be no way to stop your descent into the black hole, you can observe the universe through this window, observing the light from galaxies that stream in and witnessing the effects of exploding stars over eons. As you fall further into the black hole, its throat narrows, capturing all of this light into a bright whiteness like a tunnel. You know the term light at the end of the tunnel, but the only thing is that the light here is a sign that there is no hope. The general theory of relativity predicts that as you fall toward a black hole, you will be stretched, crushed, and broken into pieces. The intense gravity at the center of the black hole causes space-time to warp and collapse, creating a singularity where all paths come to an end. As you are dragged towards this singularity, you are battered and destroyed by the intense forces of gravity and motion. Eventually, your atoms will be ripped apart and scattered across the singularity, leaving nothing behind but empty space, intensifying the whole black holes are just infinite beings of nothingness idea, also known as the singularity. What really is the singularity? The singularity at the center of a black hole is considered to be one of the most mysterious and intriguing phenomena in physics. It's a place where matter is compressed down to an infinitely small point beyond our conventional understanding of time and space. While scientists believe that this singularity must exist, they are not exactly sure what it is or how it arises. Some theories suggest that it is replaced by an alternative state of matter or energy, but there are other theories at play here too. Could the singularity be a false idea? Many scientists believe that deep within black holes, matter does not become infinitely squished down into a tiny point, but instead takes on the smallest possible form it can. This is known as a Planck star, an intriguing theoretical concept proposed by the theory of loop quantum gravity. Proponents of this highly hypothetical model believe that space and time are made up of tiny discrete chunks at an incredibly small scale, giving our universe a granular and quantized nature. Some have argued that the discreteness of space-time provides two important benefits. Firstly, it helps to explain gravity in a more natural way, and secondly, it prevents singularities from forming inside black holes. As matter collapses under the immense weight of a collapsing star, it collides with these tiny space-time chunks, creating a ball of matter that is much smaller than the Planck length, but never infinitely small. So, in a way, things could exist beyond a singularity, and the entire black hole itself would just be a temporary blip in the overall scheme of things. But how can a black hole be temporary? Could it collapse in on itself? Black holes are some of the most mysterious and fascinating objects in the universe. Their enormous size and powerful gravitational pull give them a pivotal role in how galaxies form and evolve. But what truly makes black holes so intriguing is their event horizon, or the size of a black hole. This property is directly connected to the mass of a black hole, meaning that the larger a black hole is, the bigger its event horizon will be. Despite losing mass over time due to Hawking radiation, black holes do not disappear completely for many millions or even billions of years. In fact, even after their event horizons have shrunk significantly, the interior of the black hole remains at an infinite density and cannot collapse any further. So even if a black hole swallows everything in its path, it could just exist across time without a problem. Black holes carry secrets of ancient times. Astronomers have discovered 6 ancient galaxies surrounding a supermassive black hole from the early days of the universe. This groundbreaking find helps to shed light on how supermassive black holes formed and grew in the very early stages of the cosmos, as well as supporting the theory that they can grow rapidly within large web-like structures that are full of gas. Excited by this discovery, researchers are eager to learn more about these fascinating and mysterious cosmic objects. Even though they still don't understand how black holes can grow so quickly within such large webs of gas in the early universe, it's opened up a door to understanding the extent of information black holes might be carrying. So the scientists have gone further in to explore what else might be there. Recently, astronomers used the European Southern Observatory's Very Large Telescope observed several galaxies surrounding a supermassive black hole, all embedded within a vast cosmic spider's web of gas extending to more than 300 times the size of the Milky Way. The first black holes are thought to have formed from the collapse of the first stars in the early universe. These black holes must have grown very quickly in order to reach 1 billion solar masses within the first 900 million years of the universe's life. However, astronomers have struggled to explain how sufficient amounts of black hole fuel could have been available to enable these objects to grow so quickly. However, the web-like structure may provide the answer. This structure is made up of galaxies and contains enough gas to provide the fuel needed by the central black hole to become a supermassive giant. In other words, this may be how the first black holes were able to grow so quickly in the early universe. While more research is needed to confirm this hypothesis, the discovery of this web-like structure offers an exciting new perspective on how black holes may have formed and evolved over time. Is there a method to the madness? Are black holes always in the center of a universe? Black holes are some of the most mysterious and fascinating objects in the universe. They are formed when a star collapses under its own gravity, creating an extremely dense object with an intense gravitational pull. Most galaxies, including our own Milky Way, are believed to contain at least one black hole at their center, and some galaxies are believed to contain several. These black holes can be detected based on their effects on their surrounding environment, such as emitting large amounts of radiation or bending light from distant stars. Additionally, smaller black holes may exist throughout the galaxy in the form of stellar mass black holes formed when stars collapse. So technically, black holes could be vertically anywhere throughout the galaxies, and no, they're not always ginormous. There has been evidence of tiny black holes existing too, so if you think about it, space is just a massive home ground for black holes to exist. The terrifying discovery that could change everything. In October 2018, a small star was violently ripped to shreds when it wandered too close to a black hole in a galaxy 665 million light-years away from Earth. This is called a tidal disruption event, or TDE. These are powerful phenomena that occur when a star comes too close to a black hole, causing it to be stretched and spaghettified by the intense gravitational forces of the black hole. Though the event came as no surprise to astronomers who regularly observe these violent outbursts, a recent observation has captured the attention of scientists around the world. Nearly 3 years after this tragic event, the same black hole has reawakened and is ejecting material at incredible speeds, reaching half the speed of light directly toward Earth. This changes everything. For decades, the main concept of black holes and the way they work has been what goes in doesn't really come back out, and this ejecting is the exact opposite of that. While most TDEs are known for their quick outflows of material, which can travel up to 50% of the speed of light, this particular TDE is notable for its much slower and more sustained outflow. This suggests that TDEs may experience a delay between the initial phase of consuming a star and discharging excess matter from their systems. That also means that there may be black holes out there that contain matter from years ago that they may eject at any point, and the ejected material might make it into our atmosphere and cause catastrophic events on Earth, or worse, cause a disruption event that takes Earth along with it. How all of this will progress is something we're going to have to wait a little longer to find out, but whenever that happens, you'll hear about it here first.